Hi everyone, I'm Doug Black of Inside HPC. We're at the SC24 conference here in Atlanta, and with me now is Floyd Christofferson of Hammerspace, the data orchestration company. And Floyd, tell us a little bit about Hammerspace's mission and place in the market.
Sure. Maybe the best thing to talk about is what's happening with storage, and that is, especially with the rise of AI, is data is everywhere. There's not one type of storage. Hammerspace's mission is to ensure that the silo problem of data being segmented in different vendor silos in different locations, which today interrupts global access, that we make those lines disappear. We create a high-performance global file system for multi-protocol access from the front side, no client software, users don't have to install anything, completely standards-based on the front end that provides a high-performance data orchestration and access layer to any storage on the back end. This innovative layer in the middle actually can even accelerate performance for extreme high-performance workflows in AI, HPC, and we have customers all over the world that are doing just that.
So today with HPC-AI and data being conglomerated from all sorts of different sources and in different formats, that's the key here.
Yeah, except the problem is you can't actually aggregate or conglomerate that data. The data there's too much. And so this is a phenomenon that's often referred to as data gravity, where it gets stuck maybe in one tier of storage. You dare not move it because now you're going to lose access. The problem is in AI workflows, you may need access to all the data. So how do you do this? Do you collect it all and put it into a net new repository? That's not cost effective. It's tremendously disruptive. So what Hammerspace does is enables the data to stay in place, but elevates the file system metadata out of the proprietary storage silos. So now users are all looking at the same pane of glass, the same global file system, not a shim, not an abstraction of the file. It is the file system. And at high performance. And so now, where that data lives, which storage it's on today or moves to tomorrow, users don't know or care. They simply see their file system. Whether it's, if they're coming in via S3, it looks like an object store. If they're coming in through NFS or SMB, it looks like a file system.
And your customer base, your customer types, who are you really appealing to?
We're appealing to people that have typically more than one type of storage, which is almost everybody. But it could be a small environment. It could be 200 terabytes, 500 terabytes, all the way up to hundreds of petabytes. It's software, and which means that it can scale up or out as needed to suit what the customers require.
So tell us about your focus here at SC. Maybe your more prominent news announcements. What are you focusing on here this week?
Through a lot of the work that we've done in the hyperscalers in particular, for example, Hammerspace is used to power the Llama 2 and Llama 3 AI research laboratory for Meta. This is moving data at tremendous speeds. Initial implementation, 12.5 terabytes a second between 1,000 storage nodes and 24,000 GPUs. So that's interesting and that's really cool. But what we've seen from these hyperscalers is when they buy a GPU server, within those servers are typically NVMe drives that come with the server. The problem is the more GPU servers you have, the more those drives become isolated. They fundamentally, our customers are telling us they fundamentally can't even use those because that local storage on those GPU servers is isolated. It's not protected and they can't manage it. So what we've done is actually enabled them what we call a tier 0, where we can subsume that local storage into the global file system so that becomes a significant high performance tier 0, which is now seamlessly extended downstream into whatever tiers. The key, especially for AI workflows where there's long running jobs that you have to do checkpointing, is that a checkpoint that might take 200 seconds, during which time all of your GPUs are sitting idle, we can do in 2 seconds with this architecture. Again, it's plain Linux, and we've enhanced even the Linux kernel with an NFS protocol bypass so that it takes even greater advantage. So now what can happen is, whether it's on 2 GPU servers or 1,000 GPU servers, which is the case of one of our customers, is that all of that stranded capacity now just becomes a super high performant tier 0 within your other tiers. So checkpoints could land in that tier 0. It takes 2 seconds. The GPUs are back online, and then asynchronously in the background, we can be migrating those to other storage, to other tiers, protecting it however they want. So it's really about how do we maximize the performance of the GPU workflows to keep them online, and then make whatever storage they want to migrate those to happen in the background seamlessly.
And the key is creating a borderless, siloless data environment.
Exactly. Silos should not exist. There is no one-size-fits-all storage. I get it. You have to be able to, but you shouldn't have to interrupt users or applications or take your valuable compute resources down in order to take advantage of a smart placement of the data in the appropriate tier.
GPUs hate to be idle.
Jensen says it's a sin for GPUs to be idle, and I agree with that.
Yeah.
You know.
Okay, now looking ahead for Hammerspace over the next 18 to 24 months, what's your focus?
Hammerspace is a strong contributor into the Linux kernel, and we're now expanding a lot of the capabilities. We introduced Parallel NFS 4.2 in 2018. We've got 2 Linux kernel maintainers on staff, and so in addition to innovating what we do with Hammerspace, we are also pushing innovation up into the client to make PNFS 4.2 more performant. Classic ModSim workflows in HPC is many to one, right? AI is more many to many. And so what we're doing is actually enhancing a PNFS, so you'll have a standards-based parallel file system that can handle both the many-to-many workflows you would use in AI with the classic many-to-one workflow that you would have in ModSim. So hand in hand with the improvements or enhancements we're adding to the Linux kernel, we're also extending that out within Hammerspace. We're already, powering some of the largest AI infrastructures on the planet. That's not going to decrease anytime soon. But we have to make this so that it's enterprise friendly. So it's not just the big labs that are used to complex environments, but it has to have the RAS features and all of the things that are necessary for the enterprise. We do that now, and all we're doing is going to be continuing to build on that, so it has maximum compatibility.
Okay, great stuff.
Okay.
We've been with Floyd Christofferson of Hammerspace. Thanks so much for your time.
Thank you. It's been a pleasure.